Go ahead.
Great. Thank you, John, and thanks everyone for joining me this evening. Because for you guys it's this morning. So yes, thanks for thanks for a Sunday morning audience. It's lovely to have you all join me. And yeah, I'm going to try and give you a fairly whistle-stop tour of some of my favourite fossil spots along the Yorkshire coast. And then if there's anything you want to ask me about, at the end, I'm very happy to stick around for for discussion and questions of anything that comes up really. So yes, it's as John said, it's essentially a sort of virtual field guide, and it's something that I suppose I particularly began developing around COVID time. At that time I was working as a lecturer in the University of Hull, on the southeast corner of Yorkshire, and yeah, we had to develop a lot of hurriedly develop a lot of online resources, or add to the ones we had. So a lot of what I now do is kind of building on that, both in terms of going out and about in person, but also continuing to try and engage people wherever there's interest with the Jurassic and other geological features of the Yorkshire coast, which I've had an interest in for a long time. I'm not actually from Yorkshire originally, but I've lived here now for a long time, so I guess I've become a kind of I don't know, an unofficial Yorkshireman. And the yeah, the Yorkshire coast, again, as John has alluded to, is a very famous area. I mean, Yorkshire as a county is a very famous area within the UK, but the Yorkshire coast is one of the places, and as we'll sort of discuss this evening, it's been a place where some of the very earliest thinking about paleontology and fossil science really took place. So there's a lot of historic interest as well as present day research interest. And this is just one of my typical views. I lead a lot of fossil hunts down on the Yorkshire coast. This is a bay called Caton Bay, a little bit south of Scarborough. And this is mostly, well, actually, it's middle to upper Jurassic, but there's a lot of ice age material on top of the bedrock, as we'll pick up a little bit later on. So you can actually get two bites of the cherry, really, because you can get fossils coming out of the Jurassic rocks and indeed the Cretaceous rocks further down the coast. But you also get fossils coming out of the ice age deposits that blanket a lot of the bedrock. So it's again a really rich place to find interesting specimens. Now, I'm conscious that people probably don't have a detailed knowledge of the geological structure or variety within Yorkshire. So what I have here is a map of the county of Yorkshire on the left-hand side. So you've got the coastal sections running down the sort of right-hand side of the image. So we have right the sort of the northernmost point of the map, the Tees estuary, really northeast England's industrial heartlands, where a lot of the iron and steel industry of the 19th century developed, and places like Middlesbrough provided ultimately steel to a lot of the world. And that's the beginning of the coastal section, and it's really the beginning of the Jurassic. So actually much of Teesside sits on the Triassic. And then if you work your way down the coast, you start from the early Jurassic, and then you get gradually younger. And by the time we get to Scarborough, and then just south of Scarborough, we're in the middle and then the upper Jurassic. And then, as I mentioned briefly, we have a lot of Cretaceous exposure as well. But that's not something I'm going to pick up today, really. I should also just flag that to the west of here, there are much older rocks. So actually, Western Yorkshire, predominantly Carboniferous and Permian age rocks, mostly still sedimentary, so actually does have fossil finding possibilities, but not as easy as on the coast. And then the very northwest corner, a little place called Ingleton, just marked on the map here to the westernmost edge of Yorkshire. And there are some Ordovician rocks exposed around Ingleton, so there are some very old Paleozoic fossils there as well. So yeah, within the county, we can work through most of the Paleozoic and then most of the Mesozoic, and then there's quite a lot of younger stuff on top of that as well. And again, just for broader context, we're looking at the region here, the northeast of England. Of course, there's enormous geological diversity in Scotland, but in England, mostly sedimentary rocks, quite a lot of variety, and Yorkshire quite nicely encapsulates a fair bit of Britain's geological history. So it's a good area to spend time exploring, and I say particularly for a Jurassic story. What became known as the Dinosaur Coast in the 1990s is still an area that has lots to tell us. So again, I'll sort of talk about some of my favourite places as we go along the coast, but there are places that haven't had a lot of study and which hopefully will see that research taking place in the coming years. The beginnings, I mentioned, it has a really old history. So this is really the first geological map of the Yorkshire coast, produced in 1822 by the Reverend George Young, who was a minister in Whitby. So he was based in what's still the kind of heart of Yorkshire coast geology, but he spent well, it was a remarkably quick piece of work. I think he spent a couple of years really going out on the coast and moving inland and mapping the geology of the coast and region. This was only a few years after William Smith had produced the first geological map of England and Wales. So Smith had laid the foundations, and then others built the detail. And in fact, William Smith's nephew, John Phillips, became one of the really leading Yorkshire and Yorkshire coast geologists. But yeah, there's this map from Young and Bird. It's confusing in certain ways because they orientate the map in a different way to most of our conventional maps. It's not really north-south well, it is north-south, but the north is to the left and the south is to the right. So you've got, again, the Tees estuary here, and then we work our way down the coast. There are two particular headlands, Filey, Brig, which we'll mention, and then Flamborough Head, which is the chalk, the Cretaceous headland. And then by the time we get east of the chalk headland at Flamborough, we're into the Ice Age, the Quaternary deposits, which make up most of the southern coast of Yorkshire, down to the Humber estuary. As I mentioned, I worked in Hull for quite a few years. So Hull's the main city on the Humber estuary. I live currently in York. The funny thing here is that Middlesbrough is the main town on the North Yorkshire and certainly Teesside region. In 1822, it didn't exist because the iron and steel industry hadn't yet taken off. So Middlesbrough was a tiny hamlet in the 1820s, and then it very rapidly grew in the 19th century as the iron and steel industry took off. And actually, that was a Jurassic story because, as we'll see in a short while, there are a lot of ironstones in the Jurassic rocks of the Yorkshire, both the coast and the moors. And so that helped to kind of drive this development of industrial North Yorkshire. Now, the numbers I put here are the locations we're going to kind of see in a bit more detail as we work our way along. So number one, at Redcar is the oldest area in the first part of the coast really that you can explore in detail, and we'll work our way along to Filey and Filey Brig into the Upper Jurassic. So we've got 1, 2, 3, 4, 5 being Lower Jurassic, then Middle Jurassic, and then well, Late or Upper Jurassic, depending we're talking time or stratigraphy. So yeah, Young and Bird have much has moved on in 200 years, but equally their work is remarkably good for providing us with an overview. So this is just the strata in kind of order from oldest at the bottom to youngest at the top within the Jurassic. And as I say, we've got 5 locations in the Lower Jurassic that I'm going to take us to, particularly because these are very good for fossils. So we have Redcar in the Lower Jurassic, then Staithes, Brunswick, Whitby, Ravenscar, and then Ravenscar's the end of the Lower Jurassic strata. And then we move into the Middle Jurassic from Ravenscar going down to Scarborough. And then finally in the Upper Jurassic around Filey, we come to the end of the Yorkshire Jurassic, and Filey Bay has somewhere beneath it, we don't really see it, the Jurassic Cretaceous boundary. So we'll spend a bit of time now going through these different locations and sort of working our way through from the beginning of the Jurassic through to the end of the Jurassic and the different fossils and environments we find along the Yorkshire coast. So yeah, early Jurassic Yorkshire, the earliest part of the story is best seen around the coastal town of Redcar, which is a seaside resort. So it has a lovely sandy beach, and it's a popular summer holiday spot, but it is very much an industrial town as well. So it was at the heart of the iron and steel making. It basically went from being a fishing town to being an iron and steel town over the 19th century. The fishing still continues today, but it's nothing like what it was in its heyday. And the iron and steel industry has essentially stopped as well. So Redcar now is in a real state of sort of, I say, challenge, I suppose, that the two big employers for much of its recent history have both declined. And part of what we're trying to do with some of our work is to make people more aware that there is tourism potential because of the amazing Jurassic rocks they have. And you can just see in the photograph here a little bit of rock exposed in the beach, which we'll now have a closer look at, because this is the Redcar Mudstone Formation, which is the lowermost unit in the Jurassic of the Yorkshire coast. It's essentially equivalent, or part of it at least, is equivalent to the units we have on the Dorset coast, where Mary Anning famously collected a lot of her fossils around Lyme Regis and Charmouth. So it's sort of earliest Jurassic, and has some at least of the same kind of fossils, although no one ever seemed to become a Yorkshire Mary Anning. So we don't have anyone who ever quite collected in the way she did down on the Dorset coast. But you can see here that the rocks in the Redcar Mudstone at Redcar Rocks are in very distinctive layers, and they're very repetitive. You get a very frequent alternation between muddier layers and then sandier or shellier layers, and it's almost certainly being driven by climate cycles and sea level changes within the Jurassic Yorkshire basin. So we think at this time, and in fact for most of Jurassic time in Yorkshire, there was a marine basin covering the area. As we'll see a little bit later on, it wasn't always fully marine, but essentially we have a variety of different marine environments, and they many times have excellent fossils. And if you're in Redcar, there is a wide variety of fossils to find, but probably the most distinctive are the Gryphea, or the early Jurassic oysters. They occur in incredible numbers. I wouldn't try to calculate how many there would be on the beaches there, but you can see in this photograph that many of these resistant ledges within the Redcar rocks are packed full of these Jurassic bivalves. And sometimes there are other bivalves, but many of them are just almost nothing but Gryphea. And here's a close-up photograph of one of the nicer specimens. You can see the curved left valve and then the sort of flatter right valve. People have clearly been finding them for centuries, probably millennia. And the legend is that they are the toenails of the devil. So people would just always call them devil's toenails. And I think this story pops up across many parts of the world of them being quite common fossils in Jurassic rocks, and people often found them and thought they were, creatures or toe clippings of strange creatures. Of course, we now are fairly happy with them being Jurassic oysters, Jurassic bivalves living on the early Jurassic sea floor. But I'm always very fond of them. They were amongst the earliest fossils I ever really found, and certainly as a student of geology at the University of Liverpool, one of my tutors was very fond of fossil oysters and got us studying them in quite a lot of detail. So I still have a fondness for them, even though they are very abundant and very common things to find. And in fact, one of the things I think is really interesting is because they have calcite shells that haven't really altered since they were living. They preserve a lot of chemical detail of the water chemistry. So a lot of researchers looking at Jurassic Sea chemistry have been able to analyze the layers of the shell, and they haven't really altered a great deal. So they can make fairly robust interpretations of what the temperature was like and how that was changing, even within the lifetime of one oyster. There's a bit more going on though, and I said earlier on, some of these places haven't seen much research until 2020, when my friend Jed Atkinson from the University of Leeds and colleagues wrote a detailed study of the Redcar Rocks succession. There hadn't been any really in-depth paleontological work for more than 100 years. So Jed and his team looked in detail all of these beds and tried to describe in more detail what was going on from layer to layer. And yes, Gryphea are very abundant, but there are lots of other things in there as well. It's quite a molluscan story. There are lots of mollusk fossils, including some very diagnostic ammonites, but lots of gastropods, other bivalves. The one little image you can probably just about see in the middle on the lower set of photographs here are sea lilies, crinoids. There are some very distinctive echinoderm fossils in some of these layers. And the key thing really for Jed's research was showing that these rocks were formed in the Hatangian, which is the first stage of the Jurassic, not too long after the end Triassic extinction event, one of the big 5 mass extinctions. And it looks like within a couple of million years of that event, that life on at least the Yorkshire seafloor was fairly diverse and fairly normal again. We don't really know what was going on in the Yorkshire successions before that, because we haven't got any exposures, but elsewhere in Britain and other parts of the world, it's very clear that they were very stressed early Jurassic environments. So at least we can say that by this point in the early Jurassic, where Redcar is now, that things had sort of recovered to something seemingly normal for certainly what would then come through much of the Jurassic. Now, there's lots to say about Redcar, but I'm conscious we want to try and have a bit of a stroll down the coast and see a few different places. And the next place I want to highlight is the village of Staithes, Staithes in Yorkshire terminology really is just harbours. So staithes are just where people had a harbour, had their ships anchored, and Staithes is one of the few quite well protected harbours on the Yorkshire coast, as it's predominantly a north-facing coast, and it's quite steep cliffs. There aren't very many places it's easy to get ships into, and Staithes is one of those that's been an important fishing base for a long time. And it's a lovely historic village to go and explore. But geologically, what's really nice, and Ian West's map, Ian actually spent more of his time doing research on the Dorset coast, but he did do some work on the Dorset coast. And Ian's map here shows that the western side of Staithes has Redcar Mudstone Formation, and then the main area of the harbour itself and the village itself is sandstone. And then as we move further east, we get back into mudstones, but they're quite iron rich. And that's part of another unit, the Cleveland Ironstone Formation, which I'll talk about in a moment. And then finally, as we move further east, we get into the Whitby mudstone. So actually, in one area, we can see four of the most important local early Jurassic units, and they're all quite different. So we can start to get a picture of how the early Jurassic of Yorkshire was changing over time. And at Staithes, it's mostly sandstone, so the fossils aren't typically as well preserved. The mudstones that we see in Redcar and certainly in Whitby tend to produce better quality preservation. The muds don't or didn't allow as much sort of degradation and disturbance, and tend to allow more of the sort of three-dimensional structure of the fossils to be preserved. But the Staithes Sandstone Formation does have some very interesting and useful fossils. So you can see here, people is a student group from, I think, the University of Derby, looking at the Staithes Sandstone. It's a classic student location to go and do sedimentology and paleontology and sort of introductory geology. The Redcar Mudstone occupies much of the very earliest Jurassic Hatangian, Sinemurian, and into Pliensbachian. The Staithes Sandstone is part of the Pliensbachian stage of the early Jurassic, so about 188 million years old or so. So we're now looking at what's 12, 13 million years after the end Triassic extinction. So that's now way in the past. What we see when we look in the sandstones is evidence of very stormy seas. So I mentioned at Redcar we have this seemingly quite regular repetition between more shelly and sandy beds and more muddy beds, and that probably reflects the sort of changing or repeating environmental energy, going from being perhaps quieter conditions to sort of more energetic conditions. Staithes early Jurassic seems to be particularly energetic, and a lot of the sandstone beds have very distinctive hummocks and swales. So you can sort of see in this cross section as a kind of a dune shape with a lump sticking out as a hummock and then going down into a swale. You can see some little ripples in here as well. And these are thought to be big seafloor storms moving sand around across the seafloor. And again, they're such good sedimentary structures that students often get taken to go and have a closer look at them. Now, the fossils are typically found in the thin mud layers that occur between the sandstones. So the sandstones are often quite big storm beds, and there isn't really much in them that is well preserved, other than the sedimentary structure. But between them, we often find shelly fossils, and this is an excuse to put a little bit Canadian research in here, because Gillian Evans and Duncan McIlroy at Memorial University in Newfoundland, they did a quite detailed study of some of the trace fossils, some of the fossil burrows that we find. So we think after the storms had happened and the conditions had begun to quieten down, and particularly as mud starts to be deposited, mud is much more nutritious for burrowing and seabed dwelling creatures than sand is. So we tend to see a lot more evidence of seafloor activity in these muddier layers. And this little tube shape in the middle of the photograph, that's my fingertip for scales. This is quite a small feature, but this is a little tube-shaped sand-lined burrow of a thing called Schaub cylindricnus. And there are lots of really interesting trace fossils here. And what Gillian and Duncan tried to do with some 3D reconstructions was to work out how these things had formed. And they were able to show that some worm-like, I mean, there's often a challenge of working out what the creature was, but something was moving its way through the sediment, processing the muddy sediment for the nutrition and leaving the sandy material behind in the kind of lining of the burrow. So actually we find there's a lot of different interesting trace fossils here that you can start to work out what creatures on the early Jurassic seabed were doing. And that diversity tells us that outside of the storm events, which maybe even hurricanes, but big events that would have disturbed the seabed, once that happened, life kind of returned to normal and things seemed happily carry on doing what they were doing. And there are various shelly fossils as well that can be found in these successions. Now, as we move further east from Staithes into the slightly muddier and more ironstone-rich unit known as the Cleveland Ironstone Formation, what you start to see there is again, the sort of the quality of fossils improves somewhat or changes somewhat. And because in the 19th century it was realized that these layers of very iron-rich sedimentary material were worth excavating. Some of them were, I think, getting on for 50% iron content, so they were certainly for local value very good ironstones. So a lot of the coastline here was quarried for the ironstone, and this view of Old Nab, which is just the east of Staithes, this is a quarried landscape. It's not a natural feature. All of this area you can see here is where they were digging out the ironstones, and the main seam of the Cleveland ironstone cuts through this part of the cliff line. So they were really focusing a lot of interest here. Now, from a paleontological perspective, what I find really interesting here, you get a lot of body fossils, lovely Jurassic shells, things like pectins and other sort of big cockle shells and other bivalves, and quite a lot of belemnites. But in the main seam at Old Nab, where they've been digging it out, not doing it anymore, it stopped in the 1960s for good, but certainly in the 18th, 19th centuries when it was being worked. You find a lot of fossil burrows in those layers as well. And there's a rather neat symmetry because these tubes look a bit like ropes, these sort of twisted rope-like structures. You can see in this one here that it comes to a U-shaped termination, and actually inside it, a little curving shape. So you can see where the burrow was shifting position as the animal moved its way through the sediment. What's happened here is that the ironstone has actually concentrated inside the abandoned or moved on burrow. And we think a lot of the ironstone that we find in the Yorkshire Jurassic was concentrated here by the fact that the iron and the silica was indigestible to the burrowing creatures. So they were basically pooing out a lot of the stuff that they couldn't do anything with. And that then concentrated in the sediment, particularly in the burrows, and formed iron-rich horizons. So the miners of the ironstone, the people of the 19th century, were making use of where Jurassic miners had been tunneling through the muddy seabed and not making use of the iron and leaving it behind. So as I said, there's a nice kind of circularity to it. The name these ones get given, rhizocorallium, is very confusing because rhizo means root and corallium means coral, and they are neither roots nor corals. They're probably another kind of worm burrow. There's a bit of argument about whether crustaceans could have made them. But some of the researchers suggested the way they're built is more likely to be polychaete worms than crustaceans, but we never seem to find the trace makers, so it's still a bit of up for debate. Now, at this point, early Jurassic Yorkshire, I say Hertangian recovery from the big extinction event in the Triassic, Sinemurian plenes back in, things seem to be pretty normal in the Cleveland Basin, the seas that covered Jurassic Yorkshire. We have lots of different sea life, lots of happy signs of things burrowing in the seafloor outside when the storms are happening. But then things change quite dramatically. So this is a point I can start bringing in Dracula, because Dracula, well, he in the story, the boat Demeter lands at Whitby Harbour, and the dog leaps ashore and then becomes Dracula and wreaks a bit of havoc on the north of England. And so we can make that little segue in, because actually in the early Jurassic story, it's a bit of a horror story in the seabeds. And the story is really one of oceanic anoxia, or certainly seabed anoxia, and what's now become defined as the Toarcian anoxic event, one of now one of the best studied, but also one of the earliest known oceanic anoxic events, mainly because plate tectonics recycles oceanic crust. So actually going back before the early Jurassic, we don't have many places where the successions of that age or earlier are preserved. But in the Whitby mudstones and in other parts of the world, these early Jurassic rocks are sufficiently well preserved that we can look at this interval and see that something very dramatic happened in the Toarcian stage of the early Jurassic, so kind of towards the end of the early Jurassic. And the area around the Yorkshire coast has been really critical to the sort of development and understanding of this idea. So we can choose a couple of locations here, both of which I know GA has spent a bit of time at, one in my company, one in other people's company, that Brunswick Bay, and then we'll move on to Whitby. And we can explore this sort of how the fossils tell us the story of Jurassic loss of oxygen, anoxia on the seabed. And we should do a risk assessment. These places, so access is not always easy. These are some very steep bays to go down into. So yes, taking your vehicle down to some of these is risky, and I have seen vehicles get stuck at the bottom and not come out again. But the bay that we're going to here, Brunswick Bay, is a little bit further east than Stays, so we're sort of moving south and east down the coast. And we have the Middle Jurassic, which we'll explore a little bit at the top of the cliff, but the lower part of the cliff is the upper part of the Lower Jurassic, mostly mudstones. And then you can see the fishing village of Brunswick Bay, now actually mostly a tourist holiday village. Almost nobody lives there any longer. It's almost all tourist lets and sort of holiday rentals. This is just the summary of the Lower Jurassic Yorkshire Coast geology. So I mentioned some already, but we have the Red Mudstone Formation. There's quite a thick succession for much of the early Jurassic. We have the Staithes, Sandstone Formation, the Cleveland Ironstone Formation. We're now moving into the Whitby Mudstone Formation and the Toarcian stage. The Toarcian is then, as all of these stages are, is then broken up into ammonite zones. So we have the Pliensbachian zones and the Toarcian zones. Some of these names will pop up again in more detail later, but Dactylioscerus, Harpocerus, Hildocerus are some of the very distinctive ammonites from the Whitby area. And what we're going to look at now is this sort of transition from the ironstone into the Whitby mudstone and how it tells us this story of changes and actually very dramatic changes in the early Jurassic seas of Yorkshire. And Brunswick Bay is one of the most accessible places to go and do it. So it's a good place to explore the beginning of this Toarcian anoxic event. Now, if you're in the bay and you look out across the headland or out across the bay towards the headland of Kettleness, nesses are just headlands in Norse. So on the Yorkshire coast, there are lots of nesses because the Vikings came along, named a lot of these places. Kettleness is often referred to now as looking like a sleeping dragon. You can sort of see this head shape dipping into the water. That's actually another big quarry. It was another area that was extensively quarried in the 18th and 19th centuries. And funnily enough, a lot of the fossil dragons from the Jurassic have come from that quarry. So there's, again, a nice, neat kind of link. Now, I was here a couple of years ago with an aspiring paleontologist. She actually is now studying paleontology at the University of Birmingham, but she was an aspiring paleontologist at the time. And we went on a little walk into Brunswick Bay, and we spotted a chunk of rock on the bay floor, which it's got eyes in it. And we realized by, turning over and handling it, that it was part of a crocodile skull. Now, I say crocodile, it's not strictly true because these weren't quite crocodiles as we know them today. So perhaps better calling it a croc, but part of a much broader group of crocodile relatives that were swimming around in the seas in the early Jurassic. And this part of the skull, you can see that the eye sockets and then underneath part of the jaw was just there as a cobble on the beach. And this is sometimes what happens. These Jurassic mudstones have nodules in them with exceptional fossils, which can sometimes just be found, sitting on the pebbles of the beach. So you don't always need to do anything particularly clever to see them or find them. Now, for me, I'm particularly interested in the trace fossils, the burrowing story, because that tells us very much about what's going on in the seabed. So things like crocodiles or ammonites are swimming around. They can always get away from the less pleasant conditions. But if you're living on the seabed, you can't really get away so easily. So those fossils of the seabed creatures are really crucial to this story, and we can sort of burrow into this part of the story, that this part of the early Jurassic on the Yorkshire coast. What we see is a very dramatic change from that diversity of fossils, both body and trace fossils in the earlier Jurassic. We then see a very stark switch, and so animals didn't know it, of course, but things were about to change dramatically. We think that big volcanic activity in the rifting apart of South America and South Africa was pumping a lot of greenhouse gases into the Earth's atmosphere and driving some very rapid warming and sea level rise, which affected what was then the Cleveland Basin. This marks actually essentially the Pliensbachian Toarcian boundary. And what we see is that the Cleveland Ironstone Formation rocks are burrowed and the Whitby Mudstone Formation rocks are not burrowed. As I should say that at the top of this image, there are some burrows, and I'll mention this a bit more in a moment, but there's a very abrupt looking switch from the seabed being chewed up by creatures living in the mud and on the mud to the seabed becoming very laminated and very dark and very organic rich, and there's nothing seemingly burrowing at all. And it seems to represent, say, this dramatic change in the climate in the early Jurassic. So my YouTube guide is that these YouTube burrows can help us make sense of what's going on. because we have different shapes. And we can see here that the Ds are Diplocraterium, which are vertical U-shaped burrows. The Rs are Rhizocorallium, a bit like the ones we saw in the ironstone, which are more horizontal. And what we seem to get in this layer is a variety of burrows, but some of them clearly go down initially vertically and then they go horizontally. And one of the suggestions is that the sediment was increasingly unpleasant at depth. But actually, when we look through the rocks above this, this layer is the last layer which we find evidence of at least large-ish animals burrowing for about 600,000 years. So this interval with the Diplocraterium and Rhizocorallium burrows in it, just above the boundary, is the last hurrah of the burrowing sea creatures in this area, at least. And then conditions became so unpleasant and so difficult on the seabed that we just don't get any signs of anything burrowing in the mud any longer. And it's a quite sort of sobering thought that rapid change in the environment in this particular part of the sea seem to cause burrowing creatures to disappear for a very long time. So we are looking at this in terms of how the present day oceans are changing and what might happen to them in the longer term. Now, from a fossil perspective, this anoxia actually is very a good thing, because the lack of oxygen, of course, means that things that were sinking down to the seabed became very well fossilized. And we're moving into the most famous interval of the Whitby Mudstone Formation, the Toarcian rocks in the Yorkshire area, which is the Whitby Jet rock. And Whitby Jet is a very famous material, at least locally, because it's such an excellent material for making jewelry from. And this sort of layer you can see in the middle of the cliff here in Brunswick Bay is the jet rock. And in fact, you can just about see some vertical shapes in here. These are pillars of the old jet rock mines. So people actually used to go in and dig out the rock in this cliff to try and get Whitby jet from it, which is a very perilous thing to do. But people obviously, needed to make money in times when there wasn't much money around, perhaps. This is a big slab of Whitby jet. We think there were various coniferous trees being washed out into the sea at this time. The local story generally is that they're monkey puzzle trees, but Sarah Caldwell Steele, who's a researcher on this topic at the moment, says no, there's loads of different conifers and other trees being fossilized in this time. But the lack of oxygen on the seabed and the lack of burrowing creatures and the lack of disturbance meant that things that got washed out or fell down to the seabed often didn't get badly degraded, and so they fossilized very well. So we get many of the best ammonite fossils, many of the best reptile fossils, and plenty of good wood fossils, all in this interval of what was a very unpleasant time if you were a seabed dwelling creature. But if you're wanting to make fossils, it was very, very handy. And actually that allows us to move on to Whitby itself, moving a little bit further south and east down the coast. And this is the ruins of Whitby Abbey and St Mary's Church. And this is kind of, again, the Dracula story that when the boat moves into Whitby Harbour and the dog that is Dracula runs off into the town, it kind of heads off up towards the ruins of the Abbey. The Abbey and the church are sitting on top of the Middle Jurassic sandstones, which they will come to, but the town here mostly is sitting on the sort of upper parts of the Whitby Mudstone Formation. So we were able to see the beginning of this anoxic event at Brunswick Bay and work a certain way up. We then have to move on to the next location to start telling more of the story. And Whitby has a great legend as well, mentioned their devil's toenails. Well, the story in Whitby was that the ammonite fossils, which people were finding, again, probably for millennia, certainly for centuries, were snake stones, and that they were serpents that had been turned to stone by St. Hilda, who was the first abbess of Whitby Abbey in the 7th century. And it said she had magical petrifying powers and could cast the local snakes, which of course were devilish creatures, down onto the rocks below the abbey. And that was why they were found curled up on the beach. But of course they didn't have heads, so the local artisans started carving snakes' heads back onto the snake stones, and you can still go and buy them in Whitby today with the snakes' heads put back on them. But of course we now know they aren't snakes, but cephalopod mollusks, so octopus-like creatures in a coiled shell. And I mentioned we have Dactylioceras, which is a kind of ribbed finger-like shape, and dactyl, the finger element, refers to that shape. That's one of the diagnostic Whitby ammonites. Then St. Hilda has her own ammonite, Hildoceras, and then we have Harpoceras. And in fact, Dactylioceras is one of the ammonites from the lower part of the Whitby Mudstone Formation and the kind of beginning of this anoxic event. The Harpoceras specimens are more common in the middle part, the real sort of stinking part of the ocean anoxia story, and then the Hildosterus specimens start to be more visible in the upper part. So we've kind of got the ammonites marking different intervals in this period. I will come back to these two bivalves in a moment, but there are also a few belemnites around, including Youngi-Belus, which is named after the Reverend George Young. And it's an excellent little section that you can wander through. I think as GA said, you go to Saltwick Bay is a really nice spot to go fossiling, but actually if the tides are right, you can go from Whitby Harbour and work your way east along the foreshore beneath the Abbey and look for these lines of evidence. And again, we often take students there to look at the fossils and what they tell us. And one of my favourite bivalves is one of the ones in the drawing previously, Pseudomytoloides dubius, or the dubious false mussel-like shell. And these were very unusual bivalves in that they're one of about 2 or 3 species that could cope periodically with the seafloor conditions in this anoxic event. So you get almost nothing on the seabed, certainly no burrowing, but every so often there are probably just enough oxygen to allow certain specialist bivalves, and one of them most distinctively being this Pseudomytoloides, very often fool's gold preserved, so pyritized, very golden color, and often just a flat pavement and then nothing again for perhaps decades. But yeah, glimpses that maybe oxygen was there occasionally. And this is from a core that was drilled by a mine project nearby that's going down to Permian salts below the Jurassic strata, but which has conveniently gone through all of the rocks that we can see on the coast. We've actually been studying some of this rock to try and make sense in one location of how things change, rather than having to do the pulling it together from different pieces of the coastline. And if you want to read more about this, I was involved in the paper that we published a couple of years ago on this subsurface record of the Pleins-Bacchian-Toarcian environmental change, which allows to show that actually, although they were stinky early Jurassic seas, a lot of the structures, when you get into the detail of the muds, do still show that storms must have been affecting the sediments. So you don't get the sandstones that we've got at Staithes, but you do get structures in some of these layers that indicate storms were still hitting the seabed, but for some reason it wasn't making the seabed oxygenated like it had been before. I think it was such a stagnant state that even when there was a storm, it didn't really bring anything back for very long, maybe shortly for a few bivalves, but that was about it. And then as we move towards the end of the early Jurassic, we get the sort of the final part of this story. So we've had the going into the extinction, we have the Anoxian extinction, we then have the main event itself, and then we move down to a place called Ravenscar, a little bit south and east of Whitby, and that gives us a bit of the clearer picture of the recovery of the from the Toarcian anoxic event. And again, the fossils are really key to telling us what's going on and what was going on at this time. Now, again, it's a quite challenging place to get down to, Ravenscar. It's part of a big sweeping bay called Robin Hood's Bay. So Whitby's kind of to the north here, just beyond this headland. Robin Hood's Bay, small village at the north end of the bay. And then you can see the curving beds of rock here. These are actually Redcar mudstone formation. So you can go back to the oldest parts of the Jurassic here, because local tectonic activity has shifted that up somewhat. But the thing we want to see, or we can go seal spotting as well, is what are called the alum shales. And these are the upper part of the Whitby Mudstone Formation. And they were named the alum shales because they yielded a lot of this unusual, well, they yielded ingredients that were used for making alum, which is a fixative, particularly for dyes. And if you want to make clothes with purple in them, fixing the purple dye in the clothing is quite tricky. And alum is a key way of, or certainly was a key way of doing this. And it turns out that the upper part of the Mudstone Formation had real value in this. So actually, this is an image from the 1840s of the same quarry, which was a huge active alum works. They were digging out enormous amounts of shale to try and extract this, well, there were certain ingredients which they would then mix with other ingredients to make these compounds, which they could then fix the color in the in purple, particularly regal and church clothing. But the fossils in this interval are really interesting because the alum shales are kind of the beginning of the recovery from the anoxic event. The reason we can start to see things recovering is we do get some of these little clams called Dacrymia, or nut shells, nut clams, that seem to have been burrowing again. So this is after perhaps as much as 2 million years, but certainly hundreds of thousands of years, we start to get finally signs of little creatures going back into the mud. And my friend Bryony has spent the last 10, 15 years studying the bivalves in detail to tell the story of the sort of recovery of the communities in the Cleveland Basin. So we spent a lot of time, she spent a lot more time collecting thousands of specimens of these little nutshells to look at how they change from bed to bed, and then use that to try and make sense of how the conditions were changing and improving slowly out of this anoxic event. So the best fossils really typically come from the jet rock because it's the most anoxic, but you get lots of lovely fossils in the mudstones above and below. So all of these areas are really good places to go and explore for fossiling, but they also have a really interesting, say, Jurassic climate change story as well. Now at Ravenscar, as I mentioned, tectonic activities. Now when Young and Bird and Young were doing their map in the 1820s, they didn't know anything about tectonics. It had another 100 years or so to go before the idea was going to come out. But the point that they called the Peak, which is the headland at the south end of Robin Hood's Bay, essentially where Ravenscar village now is now known to be a fault, which marks quite a distinctive tectonic structure that actually is part of the broader North Sea tectonic structure that's the present day sea, really, how it formed. And that change in the tectonic regime partly explains why we then lose the early Jurassic rocks and we move into Middle Jurassic rocks. But it's also clear that the tectonism was happening in the Jurassic because there are differences in the thicknesses and the nature of the beds and fossils either side of this fault structure. And when we get to Ravenscar, we start to see the Middle Jurassic sandstones coming in, and then as we move further east and south down the coast towards Scarborough, we leave the early Jurassic behind and move into what's known as the Ravenscar group, the Middle Jurassic of the Yorkshire coast, which is mostly non-marine or very marginal marine sandstone-rich succession. So it's quite a switch from definitely marine mudstones into non-marine sandstones. This is a view of some of these rocks. If you're on the cliffs working your way down towards Scarborough, which is the main town on the sort of the North Sea coast in this area, you can see the Scarborough Castle headland in the distance, and then these sandstone beds in the foreshore at Burniston Bay. You can't quite see it clearly in here, but you can see layers in here. But when you get your eye and you find actually these layers sort of move about a bit, and you're looking at a meandering coastal river system, and these sandstones actually pick out shapes of small rivers moving their way across a coastal plain. So we've got quite a dramatic change in sea level. It's thought that actually the North Sea didn't exist yet. Cleveland Basin is what we're really talking about. But in the Middle Jurassic, there was some upwelling of magma in what's now the very northern North Sea, and that actually pushed sea levels. Well, it pushed the land up, pushed sea levels locally down, and turned what's now the Middle Jurassic of the Yorkshire coast into a kind of coastal plain. And this is really the beginning of what we call the dinosaur coast properly. So actually, you don't find dinosaurs in the early Jurassic because those rocks are, well, very occasional bits of bone, but they're mostly marine. So the fossils are marine reptiles and other marine fossils. Once we get to the non-marine Jurassic successions, we do start to move into potential dinosaur territory. You can see a layer of poorly preserved coal in here. So this is, again, a good indication that we're in a swampy, wet, terrestrial setting. It's probably never very far from the sea, but it's clearly not marine at this point. And this is one of the formations within the Ravenscar group. Now, I particularly like going to Burniston Bay because it's one of the places that we can prove it's a dinosaur coast because it's rich in dinosaur footprints. This map by Mike Romano and Martin White from Sheffield University, produced about 20 years ago now. They were the pioneers really of the last 30 years of dinosaur footprint work on the Yorkshire coast, and this is quite a switch in fossil types. Both they're trace fossils rather than body fossil, but they're also terrestrial rather than marine. And this just gives you glimpses of where footprints can be found along the Yorkshire coast. So Port Mulgrave is not far from Stade, so there's Middle Jurassic in that area. And then once we get down to Whitby, particularly once we move east of Whitby, there's lots of Middle Jurassic footprint beds, particularly at the top of the cliff, but they come down to beach level. And then down Robin Hood's Bay, once we cross the fault at Ravenscar and then head south, we hit more and more locations where dinosaur footprints get found. And in fact, they're found inland across the North York Moors as well. This is just my foot inside a big 3-toed print. So you can see the toes here. There are about 30 different kinds of footprint type that have now been described, but almost never any bones. So it's a quite curious fossilization, because because you think a bone is tougher than a footprint. Why are the footprints lasting and the bones not? Well, of course, many of them are big creatures, so making a big footprint gives you a better chance of being fossilized. But also we think that though there would have been bones in some of these layers, the sandstones were quite permeable. And so the dissolution, the dissolving out of bone material was probably easier than the destruction of the footprints, because the footprints were sand in sand. So there wasn't a difference really between the materials. And often at the interface between different beds, you can see really clear footprints, and say there are no absolute monster dinosaurs yet, because they kind of come really in the later Jurassic and Cretaceous periods, but we've certainly got sauropod footprints, stegosaur footprints, theropod footprints of various kinds, ornithopod footprints of various kinds, but we can't actually say in most cases what dinosaur made them, because there are no bones. We have other parts of the world where we can say, well, Megalosaurus was a Middle Jurassic dinosaur, so we can make some connections that this kind of footprint potentially was made by something like that. But actually, the direct proof of which dinosaurs were here is lacking, at least in terms of bones. But yeah, lots of footprints to find, and plenty more still to be done. Some interesting recent research looked at the fossil plants, which are very abundant. So the Middle Jurassic on the Yorkshire Coast, we mentioned jet in the Early Jurassic. The Middle Jurassic has a lot of good plant fossils. They're not jet because it wasn't fossilized in a marine setting. It's fossilized in a terrestrial setting. Huge variety of different plants. No flowers yet. So everything is things like ferns, mosses, and horsetails and conifers. I mentioned monkey puzzle trees as being the story for the Whitby jet, which is probably wrong, but actually there were lots of Oricariacean conifer-like trees at the time. So there were cousins of just weren't the modern monkey puzzle tree. And so what Sam Slater and colleagues at Sheffield University did here was to try and pull together the variety of different plant fossils they've got with some of the dinosaur footprints and other fossils, and trying to work out where things were living. And clearly the sauropods as vegetarians were dependent on the food available, the plant food available, and riverside habitats were probably preferred. And then of course predators would be targeting wherever their food source was. But interestingly, we don't have a clear sense of how they connect to other parts of the Middle Jurassic in Britain, where there are dinosaur bones known, but also potentially there are some quite big animals in quite small, what seem to be quite small habitats. So there's a curious question about how they were actually making a sustainable living in some of these places. But again, plenty more we could learn. And then our final section, once we got south of Scarborough, where the dinosaur footprints are particularly abundant, we cross here again is the old map, Scarborough Headland. We go down south of Scarborough. I mentioned Caton Bay very early on in my fossil hunting trips. Caton Bay is where we start to see a mixture of Middle and Upper Jurassic rocks coming in. There's quite a lot of tectonic complexity in that area. And then by the time we get to Filey, and what we now call Filey Brig, but the map here calls it Filey Bridge, is a long promontory sticking out into the sea. And this is where we see the end of the Jurassic and the beginning of the Cretaceous. But the Upper Jurassic rocks are very interesting in this area. So it's worth at least mentioning these, even though they're perhaps not as famous as the earlier rocks. So this is a Filey Brig viewed from the clifftop car park. You'll see Jurassic bedrock down at sea level, covered predominantly in glacial tills. So actually, a lot of this is Ice Age material rather than Jurassic. But the bedrock is very interesting and tells us about the later parts of the Jurassic story. And it kind of allows us to break up the Yorkshire Coast into a predominantly muddy Early Jurassic and marine, and then predominantly sandy and non-marine Middle Jurassic. And then we get predominantly limey marine Upper Jurassic. So there's again a switch in how things were working. It seems to be much more arid. So probably it was quite wet and probably a lot of sediment coming in off land masses of one sort or another in the Early and Middle Jurassic. It then seems to get drier, and we get a lot less evidence of terrestrial sediment and a lot more kind of biological carbonate sediment. And so it's known as the Corallian group. It's sometimes coral rich, not always, mostly limestones and sandstones. You can see students here looking at these quite thick layers of sandstone and limestone, quite intensely burrowed. Here, quite shelly, so lots of oysters in this picture. Seems to be quite an energetic environment again, so actually not very good for high quality fossilization. But you do find some nice specimens of snails and ammonites and other mollusks in some of these layers. But what's perhaps most spectacular at Filey Brig, and I've got friends who come from across the world to see these, particularly if you're interested in trace fossils, is that we've got these amazing exposures of what seem to be lobster networks. So late Jurassic crustaceans tunneling through this limey sea floor, building branching networks. And then what's confusing about them is that they've been filled in with later sediment and they've been cemented much more firmly than the matrix which they were formed in. So rather than being negative burrows in a solid substrate, you've now got solid burrows sticking out from a weathered out limey substrate. My friend Rich here, I worked with in Newfoundland, pointing at some of these features. Again, we've not yet found any sign of the creatures actually in the burrows, but it's likely that somewhere there will be some crustaceans in these burrows because they are found elsewhere. Um, and funny enough, there's a strange link to the west coast of North America here, because when we were studying some of these burrows, we actually set up an aquarium in Newfoundland that had some burrowing crustaceans in it. And the best place to get some of these burrowing crustaceans was the western North American estuaries, including Oregon and places like that. And so we were getting crustaceans posted across North America, so we could then put them in tanks in Newfoundland and get them to tunnel and see whether they produce the sorts of structures that we were seeing preserved in the rock record. And the name here, thalassinoides, is just because they look a bit like what we modern things we call thalassinid crustaceans produce in modern environments. The closest comparison to Filey in the present day world would be the Caribbean or the Mediterranean, because these sediments are oolitic, so very well rounded grains of limestone that are much like what happens today in places like the Grand Banks of Bahama, or the Bahama Banks, where waves are agitating in clear water. So we think Filey, Upper Jurassic Yorkshire, was probably quite Caribbean in its nature. And you can go to the present day Caribbean and find these sorts of crustaceans or similar things tunneling. So it's yeah, not perhaps the top place people go for fossil hunting per se, but has some amazing structures to go and have a look at. So yeah, just kind of wrapping up really. So the strange thing in Filey, I think, is that it has this amazing exposure, but nobody much has really studied it. There's glacial stories, there's tectonic stories, there are sedimentary stories, there are trace fossil and body fossil stories, but nobody quite has been persuaded to do the research there. And that's actually a story that plays back to a lot of the Yorkshire coast, that even if we're going to a place that's been looked at for 200 years geologically, there's a lot we don't know, and a lot of places that haven't really seen detailed investigation. So one of the things we're really trying to do is to encourage people to come and explore the coast, whether that's for fun or for research or a bit of both. So if it's something that you think you might fancy, we'd be very happy to see you and very happy to take you and explore some of these locations. We have a Yorkshire Coast Rocks project. And as I said to a few at the start, we're in the process of a charity to try and do more of this sort of earth science outreach in Northern England, using places like the Yorkshire Coast to help people understand about ancient environments and what they can tell us, including potentially for the future. So yes, visitors very welcome, and lots of great places to go and explore, and lots of great fossils still to find. So yeah, thank you for inviting me to speak. If you have any questions or comments you'd like to ask, I'm very happy to discuss them. But I will stop at that point and let you come back in with any questions you have. Thank you.